Hi, welcome to Math and Math. Today we will solve a CSIR net problem on partial differential equation. This is a part B question, so only one option is correct. The question is, the second order partial differential equation is given. So the second order differential equation is given and four options are given. Option 1, hyperbolic in the second and the fourth quadrants. Option 2, elliptic in the first and the third quadrants. Option C, hyperbolic in the second and elliptic in the fourth quadrant. Option D, hyperbolic in the first and the third quadrants. So a second order partial differential equation is given. We will find the nature of the equation by using the general form of the partial differential equation, and we will find the solution to this problem. Now, solution. So the given second order PDE is given second order PDE is. So write down the given differential equation. 1 minus root xy into, instead of writing dou square u by dou x square, let me write it as uxx plus 2 into dou square u by dou x dou y, let me write it as uxy plus 1 plus root xy. Instead of writing dou square u by dou y square, let me write it as uyy equal to 0. Or we can write this equation as 1 minus root xy into r plus 2 into s plus 1 plus root xy into t equal to 0, where uxx is r, uxy is s, and uyy is equal to t. Fine. Let me name this as equation number 1. Now we will compare equation 1 with the general PDE, general form of the partial differential equation, which is r into r plus capital T into small t plus capital S into small s plus the function of x, y, z and pq, which is equal to 0. So let this be equation number 2. So this is the general form of the second order partial differential equation, where x and y are the independent variables, z is the dependent variable, p, q, small r, small s and small t are the partial derivatives of the dependent variable, which is z, with respect to the independent variables, which are x and y. Okay, since it is a partial differential equations, so you will have many independent variables with respect to the dependent variable. So comparing equation 1 with equation 2, what is capital R, capital S and capital T? So capital R is equal to 1 minus root xy, capital S is equal to 2 and capital T is equal to 1 plus root of xy. So that is, taking the coefficient of small r to be capital R, taking the coefficient of small s to be capital S, taking the coefficient of small t to be capital T. So therefore, we will have to find capital S square minus 4RT. This we have to find, and if this is greater than 0, then we say it is hyperbolic. If this is less than 0, then we say it as elliptic. If this is equal to 0, we say it as parabolic. But in our option, we have only on hyperbolic and elliptic. So therefore we will check these two conditions and then we will come to a conclusion. So let us check for s square minus 4rt, which is equal to, what is s square? What was s? S is equal to 2. So s square will be 4 minus 4 into r. What is r? R is equal to 1 minus root xy. So 1 minus root of xy. What is t? That is 1 plus root xy. So this is equal to 4 into 1 minus of, so this can be written as, so here I have taken 4 common, so I will get 1 minus of, this can be written as a square minus b square. So that is 1 minus of b square root of xy whole square, that is xy. So here 1 and 1 gets cancelled, you get 4 into xy. So this is equal to 4xy. So therefore if 4xy is greater than 0, then we say our differential equation is hyperbolic. So when do we say that 4xy will be greater than 0? There are two conditions. Either if x and y both are greater than 0, we will have positive. So therefore 4xy will be greater than 0. Or if x and y both are less than 0, then we will have negative into negative, which becomes positive. So again 4xy will be greater than 0, hyperbolic. So if these two conditions satisfy, then this 4xy will be greater than 0, then our differential equation will be hyperbolic. So therefore x and y both are positive in the first quadrant and x and y both are negative in the third quadrant. Okay, so this is one condition which we have found. We will also find out for the elliptic. That is, if 4xy is less than 0, then we say it as elliptic. So when will 4xy be less than 0? That is either if x is less than 0 and y is greater than 0, or if x is greater than 0 and y is less than 0. If these two conditions are satisfied, then our 4xy will be less than 0. When we will get less than 0? Either if one is positive and the other is negative, plus into minus, minus. So in that case, we will have 4xy to be less than 0, which gives that the partial differential equation is elliptic. So this is in the second quadrant and this appears to be in the fourth quadrant. Okay, so this is what we have found. Let us check with the options. So just remember two things: hyperbolic in the first and the third quadrant, elliptic in the second and the fourth quadrant. We will check for the options now. So here the first option is hyperbolic in the second and the fourth quadrant. No, that is wrong. Option B, elliptic in the first and the third quadrant. No, that is wrong. Option C, hyperbolic in the second and elliptic in the fourth quadrant. No, that is also wrong. Option D, hyperbolic in the first and the third quadrants. Yes. So this is the correct option. So option D is the correct option. So whenever the partial differential equation is given, compare it with the general form of the equation. Find the nature of the equation using s square minus 4rt, whether it is greater than 0, less than 0 or equal to 0. Then decide upon the nature of the differential equation, whether it's hyperbolic, elliptic or parabolic. Thank you.